an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond.
What if the most mysterious interstellar visitor ever detected isn't just a comet, but something far stranger? An object that accelerates without clear cause, emits impossible light patterns, and follows a path so precise it feels intentional. Picture NASA's most advanced telescopes capturing an enigma that brightens fourfold within minutes and pulses with a rhythm reminiscent of signals recorded decades ago. As we examine the baffling data behind 3I/A TLAS, prepare to confront a phenomenon that challenges known physics and hints at forces or intelligence beyond anything humanity has encountered: the unexplained brightness and motion. For the first time ever, an interstellar object known as 3I/A TLAS displayed behavior that stunned scientists worldwide. Within just 6 minutes, this enigmatic visitor brightened 4 times, something no comet or asteroid had ever done before. Such rapid fluctuations in brightness baffled NASA's Jet Propulsion Laboratory and went far beyond the known patterns of space objects heating up or interacting with sunlight. Typically, comets brighten gradually as they approach the sun, driven by ice vaporizing and creating glowing dust clouds. 3I/A TLAS did not follow this pattern at all. NASA's initial data revealed the object's light increased by a factor of 5 just days after it passed the sun. Yet, despite this surge in brightness, 3I/A TLAS showed no signs of the usual comet features. There was no visible tail, no dust clouds, and no vapor emissions. The space surrounding it remained eerily clear, challenging everything researchers expect from such active cosmic bodies. To confirm these observations, multiple space agencies, including the European Space Agency and Japan's Subaru telescope, independently verified the data, ruling out the possibility of instrument error or light distortions. Even more perplexing was 3I/A TLAS's acceleration pattern. Normally, objects passing the sun slow down as they are pulled back by gravity, but this visitor defied expectations by speeding up instead. NASA described this as a non-gravitational propulsion pattern, a phenomenon that doesn't fit with any known natural forces like solar radiation pressure or magnetic fields. Scientists ran thousands of simulations attempting to recreate the object's path, but none matched without adding an unexplained external force to push it forward. Unlike most comets or asteroids driven by the evaporation of material that creates jets, 3I/A TLAS left no debris, showed no mass loss, and emitted no detectable exhaust or chemical outgassing. It appeared to move as if propelled by an unseen engine, capable of controlling its velocity and direction with precision. This behavior was unprecedented and unlike anything previously recorded within our solar system or beyond it. Economies of natural explanation seem to fall short entirely, opening doors to possibilities that extend outside established scientific models. NASA's cautious scientists admitted the discovery was extraordinary, and the European Space Agency reinforced this view, calling it a phenomenon that transcends current physics. The implications sent shockwaves throughout the scientific community, prompting urgent new investigations into the nature of this anomaly. For decades, all known comets and asteroids adhered to the predictable laws of gravitational pull, yet 3I/A TLAS seemed to chart its own course, reshaping our understanding of interstellar visitors. One of the most mind-boggling aspects is that 3I/A TLAS appeared almost aware of being observed. Its unpredictable brightness and acceleration hinted at a responsiveness that betrayed natural randomness, as if something inside it, or guiding it, adjusted its behavior consciously. This raises profound questions about its origin and purpose. Is it a natural object, or something engineered? The boundary between cosmic rock and machine seemed to blur as new evidence unfolded. This initial mystery sets the stage for deeper inquiry into the object's physical makeup and what lies beneath its surface, aspects that further compound the puzzle. With brightness and motion defying every known rule, scientists are left searching for clues beyond the conventional, anticipating that the truth could alter everything we believe about extraterrestrial phenomena. Our curiosity about 3I/A TLAS's strange behavior leads us to examine what this visitor is made of and why its composition refuses to fit the natural patterns we expect. Composition and surface anomalies. When scientists turned their instruments toward understanding what 3I/A TLAS was made of, the findings confounded every assumption about interstellar comets. Rather than the icy, dusty and rocky makeup typical of such celestial bodies, 3I/A TLAS showed a chemical signature that suggested something entirely different. NASA's Jet Propulsion Laboratory detected extremely high levels of nickel but almost no iron, an unusual and unnatural pairing since these elements typically coexist in stellar material. Further baffling was the near absence of water, less than 4% of what is usually found in comets passing through our solar system. This scarcity ruled out formation in the cold, icy outskirts of stellar systems. Instead, the chemical fingerprints pointed to an origin near intensely hot environments, such as planetary cores or dying stars, places where natural ices and gases simply cannot survive. Some scientists speculated that 3I/A TLAS might be a fragment of a long-lost world, shattered and cast adrift across the cosmos. Optical observations deepened the mystery. The object's reflected light was bluer than sunlight, indicating it reflected more energy than it absorbed, behavior consistent with polished metals rather than frozen rock. The polarization of reflected light was negative, meaning photons bounced off in directions physics does not usually permit. Only a few engineered materials on Earth can replicate such a property, hinting at a possible artificial surface, or at least one unlike any natural body in space. Thermal mapping revealed an exceptionally uniform temperature across 3I/A TLAS's surface, even when sections faced direct solar exposure. Typical comets develop hot and cold zones that cause cracking and material shedding, but this object remained perfectly stable, as if coated in a metallic shell capable of conducting heat evenly. It gave off bursts of ultraviolet light stronger than any known comet, and spectral analyses suggested the presence of alloys capable of absorbing and releasing radiation in controlled cycles, much like thermal management systems on advanced spacecraft. By late November, observations from Chile's Very Large Telescope confirmed the object appeared composed of a single continuous material. Natural celestial objects invariably display variations in texture and density, but 3I/A TLAS was strikingly smooth, bright, and perfectly balanced, almost mirror-like. This uniformity suggested something engineered for endurance and precision rather than a chance assembly of cosmic debris. While NASA has not officially declared the object artificial, the mounting evidence points in that direction. It is not behaving like a typical interstellar rock. It seems to possess qualities more akin to a crafted probe or vessel engineered for extended space travel. These discoveries challenge the very nature of what types of objects can enter our solar system and what technologies might exist far beyond human reach. Such extraordinary composition raises fundamental questions about the object's provenance and history, compelling scientists to rethink the boundaries between natural cosmic phenomena and engineered constructs. Understanding its makeup is key to unraveling the mystery behind its motion, brightness, and behavior. The revelations about 3I/A TLAS's material complexity lead us to consider its unusual trajectory, one that appears designed rather than random. What does its path through our solar system tell us about its origin and destination? Precise orbital path and gravity assists. Unlike most interstellar visitors, which arrive on steep, unpredictable paths cutting across the solar system, 3i/ATLAS charted a remarkably flat orbit, closely matching the plane in which the planets revolve. This near-perfect alignment, deviating by only a few degrees, is statistically almost impossible for a random object entering from interstellar space. It suggests the object was traveling along an established route, as if on a mapped cosmic highway, instead of scattering randomly through the solar system, adding to the extraordinary nature of its path were its close approaches to Venus, Mars, and Jupiter. Distances ideal for gravity assist maneuvers. These are well-known techniques employed by human spacecraft to gain speed without expending fuel, using planetary gravity to slingshot into faster or altered trajectories. For an object like 3i/ATLAS to naturally replicate this pattern borders on the inconceivable. Statistical estimates place the odds of such a coincidence at about 1 in 50,000. During over 30 consecutive days of observation, data from the European Space Agency's Gaia Observatory confirmed that 3i/ATLAS maintained a steady, smooth acceleration rather than the chaotic motion one might expect from random solar or interstellar forces. It was as though an unseen engine was driving the object continuously, managing its speed and course with precision. This consistent propulsion further distances it from any natural comet or asteroid origin. Speculation about the object's structure includes theories that it might be hollow or partially metallic, using solar heat to generate thrust internally. Others hypothesize it could be a fragment from a star system governed by unfamiliar physics. However, none of these naturalistic explanations can fully account for the object's directional thrust or the extraordinary stability of its flight path. Every detail of its trajectory points to control, deliberate or otherwise. The distribution of light reflection also defied natural expectations. Unlike common cosmic bodies that wobble or spin irregularly, 3i/ATLAS's reflected light was remarkably steady and uniformly spread. This uniformity implies a surface so finely tuned that it could be adjusting its orientation to trade light or energy with the sun intentionally, almost as if equipped with adjustable panels or shields. Astronomers from the European Southern Observatory dubbed the surface behavior optically controlled, describing it as an interaction with sunlight more complex than mere reflection. This kind of dynamic surface response had never before been recorded on a comet or asteroid, hinting at advanced materials or technology beyond natural formations. As scientific interest deepened, questions moved beyond just how the object moved to why it moved this way. Was 3i/ATLAS merely drifting, or was it navigating purposefully through the solar system? The elegant dance it performed with planetary gravity suggests a mission, not a chance encounter. This intricate orbital choreography demands that we look even closer at the signals the object emits, signals that may finally offer insight into its true nature and origins. The subtle shift from orbit to signaling light flashes invites us to explore how 3i/ATLAS communicates, or whether it does so at all. Light pulses and possible signal patterns. As 3i/ATLAS continued its mysterious journey, it began to do something no comet or asteroid ever had before. It pulsed with bursts of light on a precise schedule. For days, telescopes around the world recorded flashes every 17 minutes, repeated 3 times before pausing, then restarting. The regularity of these pulses was unlike any natural phenomenon, looking more like a deliberate transmission or coded signal. Scientists initially considered that the effect might be caused by the object's rotation, with sunlight reflecting off uneven surfaces. But this idea soon fell apart when the rotation speed did not match the timing of the light bursts. Independent confirmations from the European Space Agency and Japan's Subaru telescope ruled out instrument error or interference from nearby bodies. The light pulses originated directly from 3I/ATLAS itself, leaving no doubt that the pattern was real and intentional in appearance. This precision suggested that the flashes were not random events but repetitions of some unknown process or message. The possibility that the object was actively releasing energy in these cyclical bursts opened new questions about its nature. Was it communicating, signaling, or simply responding to environmental factors with extraordinary timing? Researchers soon noticed a startling connection. The timing of these light pulses matched the ratio of the infamous WOW signal detected in 1977. The original WOW signal was a brief, narrow-band radio transmission coming from the direction of the constellation Sagittarius that has never been explained. Now, nearly 50 years later, 3I/ATLAS seemed to echo this same pattern, but in optical light instead of radio waves, like a cosmic mirror reflecting a long-forgotten message back across time. This mirror sync pattern led some independent researchers to propose that 3I/ATLAS was a messenger responding to humanity's earliest signal attempts in the search for extraterrestrial intelligence. While NASA has neither confirmed nor denied this interpretation, their official statement described the synchronization as an anomaly of unknown origin, leaving the door open for profound possibilities. The pulses maintained their precision for several days before fading, almost as if the object acknowledged it had been detected and then intentionally ceased its signal. Astronomers described the light sequence as a language composed of precisely timed flashes, just long enough to prove it was no accident. The resemblance to the original WOW signal suggested these two events might share a source, raising the unsettling prospect that humanity was witnessing the continuation of an interstellar conversation begun decades earlier. Whether the pulses carried specific information or served simply as recognition remains unknown, but their deliberate timing and structure demand attention. After the pulses stopped, an eerie silence fell over the data, as if a message had been delivered and the cosmic sender was now waiting patiently for a response. If light can carry memory across space, then perhaps this was the moment humanity finally heard something answering back, a faint but unmistakable recognition echoing through the cosmos. The secrecy and subtlety of the signal hint at intelligence far beyond our current understanding, cloaked within a visitor that defies all expectations. This extraordinary phenomenon made scientists worldwide reevaluate what objects like 3I/ATLAS might represent. Could it be a probe, a drone, or even an artifact sent to observe and communicate? As the pulse data rippled through research communities, it ignited both fascination and debate over whether humanity was witnessing first contact or merely interpreting natural phenomena wrongly. The light pulses have transformed 3I/ATLAS from a cosmic curiosity into a possible herald of something far greater, pressing the question, what can we learn by comparing it to the other interstellar travelers that came before? Comparisons with previous interstellar objects before 3I/ATLAS, humanity had encountered only two confirmed interstellar visitors, Oumuamua in 2017 and Borisov in 2019. Both offered clues about objects traveling between star systems, yet neither prepared us for the extraordinary nature of this latest arrival. Oumuamua was the first known object from outside our solar system with an elongated shape and mysterious behavior, lacking a visible coma or tail, but showing slight non-gravitational acceleration, possibly from solar radiation. It challenged norms but still fell within some stretch of accepted physics. In contrast, Borisov presented as a more conventional comet, exhibiting dust, gas, and a bright tail consistent with its activity sourced from solar heating. Borisov confirmed that natural interstellar objects behave in ways familiar to astronomers, following the expected rules of cometary physics. It was a reminder that space can surprise without overturning foundational scientific laws. Then came 3I/A/TLAS, which shattered this fragile order. Unlike Oumuamua and Borisov, it showed no dust, gas, or ice, yet accelerated contrary to gravitational expectations. While Oumuamua entered the solar system at a steep angle, 3I/A/TLAS travelled almost perfectly along the ecliptic plane, the path planets follow around the Sun. This alignment with planetary orbits hinted at purposeful navigation, an uncanny precision missing in both predecessors. 3Y/A/TLAS also brightened as it moved away from the Sun, opposite the expected dimming seen in both Oumuamua and Borisov. Its light reflected in smooth, uniform waves, not scattered by dust but seemingly rebounding off a polished surface, suggesting a metallic or engineered exterior. Neither previous visitor displayed such optical control nor emitted repeated timed pulses that could be interpreted as signals. Scientifically, 3I/A/TLAS is a hybrid anomaly, combining elements of both Oumuamua's mysterious acceleration and Borisov's comet-like trajectory, yet behaving according to no known natural laws. Its characteristics raise unsettling questions about the diversity of interstellar objects and whether some might be artificially constructed or directed. The distinct differences highlight that not all cosmic visitors are cut from the same cloth. Some scientists now speculate that these three arrivals are not isolated incidents, but chapters in a broader cosmic narrative. Could Oumuamua have been a scout, Borisov a natural control, and 3I/A/TLAS the real messenger, endowed with unknown technology or intelligence? The timing of these discoveries, arriving within 8 years of each other, adds weight to the theory that they represent stages in an ongoing interstellar process or communication. Whatever the truth, 3I/A/TLAS has redefined the boundaries of what an interstellar object can be. It emphasizes that our solar system is not isolated but part of a vast cosmic network where unknown entities pass through, some natural, others potentially designed. As observations improve and technology advances, unraveling the mystery of these visitors may reveal secrets central to humanity's future in space. The dramatic divergence of 3I/A/TLAS compels a new focus on global observation efforts, pushing astronomy into an unprecedented era of collaboration and discovery, global observations and future research. As 3I/A/TLAS continued its mysterious path, observatories worldwide rapidly coordinated to study the object. Solar telescopes in Chile, Japan, Hawaii, and the Canary Islands recalibrated to capture its faint post-solar passage, while European and Asian networks shared real-time data for the first time, forming a unified global monitoring feed. This unprecedented collaboration reflected the scientific community's urgency to understand every aspect of the object's behavior. Radio arrays in Australia and South Africa heightened their sensitivity to detect low-frequency signals associated with its motion. Additional agencies joined ongoing campaigns, confirming through diverse instrumentation that 3I/A/TLAS was unlike any known comet. Governments in the United States and Europe announced joint observation strategies extending into 2026, including new deep space probes designed to study the object when it re-enters visible range. When 3I/A/TLAS reappeared, its properties remained strikingly unusual. Uniform surface temperature, precise light reflection, and no observable degradation under intense solar radiation. Its steady, deliberate trajectory challenged conventional models and reinforced the conclusion that it was not an ordinary interstellar rock. Scientists affirm the reliability of the data while avoiding definitive interpretations. The object's consistent thermal, spectral, and visual readings raise profound questions about its nature. If its motion or structure proves self-regulating or engineered, it could redefine categories of interstellar objects or suggest technologies beyond current human understanding. Growing public curiosity and internal debate accompany these discoveries, prompting discussions about transparency and potential implications. As international agencies continue to coordinate, 3I/ATLAS stands at the frontier of scientific exploration, pushing humanity toward new methods, new collaborations, and new questions about our place in the cosmos. 3I/ATLAS has challenged everything we thought we knew about interstellar objects, from its baffling brightness and composition to its precise navigation and mysterious signals. As global science unites to unravel these mysteries, one thing is clear: the universe still holds astonishing secrets waiting to be uncovered. If you enjoyed this deep dive into 3I/ATLAS, don't forget to like and subscribe for more mind-expanding journeys into space's greatest enigmas.